In this video, we learn how to solve indicial or exponential equations by factorization. Okay, so solving indicial equations or exponential equations by factorization. So the outcome we expect here is to be able to solve equations like 2 raised power x plus 1 plus 2 raised power x equals 96. So clearly you can see that this 96 cannot be written as 2 raised power something, but there's a way we can handle the left hand side so that at the end of the day we can factorize and divide through by a particular value that will now end up so that end up having 96 having something from this 96 that can be expressed as uh you know in index form in terms of 2. So let's go ahead and remind ourselves what an indicial or exponential equation is, which I've done in some previous videos, but it's never too much. An indicial exponential equation is one where the variable appears in the exponent, like when you have 3 raised power x equals 27, 5 raised power 2x equals 125, 2 raised power x plus 1 plus 2 raised power x equals 96. Now, when terms have the same base, we can solve by simply rewriting using exponent laws. We can factorize, we can substitute if needed. In the last video, we considered solving indicial equations by substitution. So, like if you look at this first example, all we just need to do is to rewrite this as as having the same base. So you have 3 raised by x equals 3 raised by 3. So it means x is simply 3 here. So we can also rewrite base here. We have 5 raised by 2x equals 5 raised by 3. So that means 2x is equal to 3 and x is 3 over 2 simply. But in this case, it's not easy to go that way, and that's why we are considering this factorization method. Okay, so the essential exponent laws we are going to use here, I think in the second video on that is playlist, we talked about the laws of indices. So we saw this law, for instance, we saw it as the the power, is it power law now? Yeah, the um yeah, I think it is the product law, exactly. This is the product law of indices, where if you have a raised power m times a raised power n, you can easily write it as a raised power m plus n. And of course, the other way is also true. If you have a raised power m plus n, you can split it up as a raised power m dot a raised power n. Then we also had the quotient law of indices, where a raised power m divided by a raised power n means a raised power m minus n. And of course, the reverse is true. So if you have a raised power m minus n, you can split it up this way. Then we also have the power of a power. So if a raised power m is raised power n, then you can just simply multiply the powers and you get that expression. Okay, so based on those rules now, first, if we want to look at the first method where we factor out the smallest power. So this is the most important technique actually, where you factor out the smallest power. So in this example one, imagine what you have here. You have 2 raised power x plus 1 plus 2 raised power x equals 96. Like I said, you can't see any clear way to express 96 as 2 raised power something, but what do? You rewrite using exponent laws. First of all, 2 raised power x plus 1 can be written as 2 raised power x times 2 raised power 1, which is the same thing as 2. Okay, so in that case now we can say 2 raised power x plus 1 is the same thing as 2 times 2 raised power x plus this 2x equals 96. But then another thing we can do is to factorize. So now we have 2 into 2 raised power x then plus 2 raised power x again. So we can simply factorize. And when we factorize, it means we have 2x is common to both sides. So if you take 2x from 2 times 2 raised power x, you get 2x out here, and you have this 2. Okay, you have this 2 left, and then when you do this one, you have this 1 left. That is equal to 96. Okay, and then that means you have 2 raised by 2 plus 1 is 3, so it means you have 3 multiplied by 2 raised by x equals 96. By the time you divide through by this 3 now, you have 2 raised by x equals 96. And that means if you divide 3 by 3 rather, you have 2 raised by x equals 96 divided by 3, which is 32. Now, you can write 32 as 2 raised by 5, and then you get x as 5. Well, I mean, for the sake of emphasis, I want to solve that on the worksheet. So 2 raised by x plus 1, 2 raised plus 2 raised by x equals 96. Okay, we have 2 raised by x plus 1 plus 2 raised by x equals 96. So as usual, we can't clearly write 96 as 2 raised by something. That's what I was trying to explain. So, but here we know that this is the same thing as 2 raised by x times 2 raised to power 1 plus 2 raised to power x here equals 96. Okay, so next we know this can be written as 2 into 2 raised to power x plus 2 raised to power x here equals 96. So from this expression and this expression, we know 2 raised to power x is common. So we can have 2 raised to power x out here into 2 into 2 raised to power x. Since you are factorizing this, you have to divide by that. And then on this part, you have 2 raised to power x all over 2 raised to power x. Since you are taking it out like that, and that is equal to 96. So 2 raised to power x cancels this. Okay. And then we have 2 raised to power x into, if it cancels that, we have 2 here. 2 raised to power x over 2 raised to power x is 1 right there, and that is equal to 96. Okay, so it means we have 2 raised to power x multiplied by 3 equals 96. So that means you have 3 into 2 raised to power x equals 96. So we can then divide both sides by 3. So we have 3 into 2 raised to power x all over 3 equals 96 all over 3. Okay, so this cancels out. So we have 2 raised to power x equals 32 because 3 in 9 is 3, 3 in 6 is 2. So now we can write 32 as 2 raised to power something though. So we have 2 raised to power x equals 2 raised to power 5. So we can equate this to, and then we say x is equal to 5. And of course, as usual, I like to check. You want to check to see if what you have done is right. We got x to be 5, right? So that means we have 2 raised to power 5 plus 1 plus 2 raised to power 5. So 2 raised to power 5 plus 1 is 2 raised to power 6. Then this is 2 raised to power 5. 2 raised to power 6 is 64. 2 raised to power 5 is 32. 64 plus 32 is 96. So we are good to go. Okay? So that's how that goes. Now, having explained that, okay, of course, we got x to be 5. So we have second method. For the second method now, we have this. We want to solve sum or difference exponential equations. Same idea, basically. So we have 3x plus 1 minus 3x equals 54. So step 1, we have to rewrite. 3 raised to power x plus 1 is the same thing as 3 times 3 raised to power x. Or if you like, 3 raised to power x times 3 raised to power 1. Same. So that means you have 3 into 3 raised to power x minus 3 raised to power x equals 54. And again, we can factorize. So you can factorize 3x. So that means you have 3 raised to power, 3 raised to power x. So that means you have 3 raised to power x into 3 minus 1. That is, if you take this out, you have to divide both sides. So cancel this, you have 3x over 3x 1 equals 54. So 3 minus 1 is 2. So 2 into 3x is equal to 54. So by the way, there's no way you can write 54 as 3 raised to power something on its own, except until you have factored something out. So you have 2 into 3 raised to power x equals 54. So if you divide both sides by 54 now, by 2 rather, you have 3 raised to power x equals 27. Now 27 is 3 raised to power 3, so that means you have 3 raised to power x equals 3 raised to power 3, so x is equal to 3. So if you check, you discover that also works. So if x is 3, you have 3 raised to power 4 minus 3 raised to power 3. So 3 raised to power 4 is 81, 3 raised to power 3 is 27, so 81 minus 27 is clearly 54. So we go for another method right here, hidden common problems. Hidden common factor problems. Sometimes the common factor is not immediately obvious. So when the common factor is not immediately obvious, what do you do? So you have 5 raised to power 2x plus 5 raised to power x equals 20 now. So step 1, use substitution. So 5 raised to power 2x, it can be written as 5 raised to power x raised to power 2. So in that case, now if you now say let y be 5 raised to power x, so you have y squared plus y equals 30. And then you have a quadratic expression, which is y squared plus y minus 30 equals 0. So if you factorize, you have y plus 6 into y minus 5 equals 0. So y is equal to minus 6, so y equals 5. So, but don't forget, you started with 5 raised to power x. Okay? So you now take it back. So since y is 5 raised to power x and exponential expressions are always positive, so it means you cannot say that y raised to power you cannot say that 5 raised to power x is minus 6. So we reject this minus 6 and we focus on y raised to power y equals 5. So you have y equals 5, which is 5x equals 5 raised to power x equals 5. And that means 5 raised to power x equals 5 raised to power 1. So x is simply equal to 1. So you can easily check that, right? So because x is 1, you have 5 raised to power 2 times 1. That's 25 plus 5, which is 30 easily. Okay? but y could not have a minus 6 because 5 raised power x will be positive. So we have example 5 now. So in this case, now you could see the factor was not clear. We couldn't take the number out and then simplify, but we had to solve the quadratic expression emanating from that. So you have 2 raised power 2x minus 5 into 2 raised power x plus 6 equals 0. So you can substitute. We already see that 2 raised power 2x will be 2 raised power x squared. So if you let y be 2 raised power x, so it means you have y squared minus 5y plus 6 equals 0. So that's easy to factorize, right? We just factorize this. We have y equals y minus 2 into y minus 3 equals 0. So y is equal to 2 or y is equal to 3. Then you can substitute back. Don't forget, we said y is 2 raised power x. So for 2, 2 raised power x is 2. And then we get x equals 1 because 2 raised power x is equal to 2 raised power 1. Then for case 2, we get 2 raised power x equals 3. That means x is log 3 base 2, which you can easily find by punching your calculator. So using the response, that's log 2 base 2 of 3 log 3 base 2, which is 1.585. Okay, if you want to get that, but that's it there. So we've run through all that. So the systematic strategy for solving exponential equations here is this. Step one, make bases the same if possible. Step two, rewrite using exponent laws. Step three, factor out the smallest power. Step four, if necessary, let y be a raised power x or whatever, anything, p raised power x, anything you choose. Step five, solve the resulting linear quadratic equation. Step six, substitute back and check for invalid answers. We've always done that. So common mistakes. So these are some possible mistakes that can be made. It is incorrect to say that 2 raised power x plus 1 plus 2 raised power x is the same thing as 2 raised power x plus 1 plus x, and then you get 2x plus 1. That won't work. You can't simply just add this because they don't mix like that, okay? But of course you can break it down and say, okay, I mean, let me try to explain that. So you have 2 you have 2 raised power x plus 1 plus 2 raised power x. It is incorrect to say it is 2 raised power x plus 1 plus x, and then you now get 2 raised power 2x plus 1. That would be totally incorrect. However, if you have 2x plus 1 plus 2 raised power x, 2 raised power x plus 1 plus 2 raised power x, that's the same thing as having 2 raised power x times 2 raised power 1 plus 2 raised power x, which you can then write as 2 into 2 raised power x plus 2 raised power, well, I mean, you can factorize because 2 raised power x is common, so you can have 2 raised power x into 2 plus 1, and that is the same thing as 2 raised power x into 3, you know. It's so that means this is written as 3 multiplied by 2 raised power x like this. So they are totally different. Pay attention to that. If not, you get it wrong. Okay, so exponents cannot be added across addition. That's the deal here. So remember that exponential expressions are always positive also. So whenever you have, whenever you get, after substituting 5x, 5 raised power x, or a raised power x for that matter, a raised power x can never be equal to anything negative. It can't be anything negative. Okay? So it can't be, yeah, it can't be like that. Okay, so yeah, we have practice problems. As usual, I like to take two, maybe one out of first 10, another one out of second 10. Which one should I go for now? Um, I don't know. Okay, I see minors here, so let's see what that looks like. So as usual, I'm going to snip it so I don't have to keep going back and forth. So I pick this now. Then I pick this one that has minus in it. Okay. So then I can copy that. I just copy. Then I come to the worksheet. Okay. Then I click here and I paste. So we have this. We need to solve that, right? So now I pick this 5 raised power 2x. So I mean, clearly we cannot write anything as the base of anything as from all we can see. So that means but we can see that 5 raised power x raised power 2 can come from this one. and then minus 6 into 5 raised to power x equals minus 5. So from here already, yeah, we can, there's no point even trying to factorize, so we can just substitute straight. So we can say let 5 raised to power x be equal to um let me use something new, is equal to b. Okay, so that means b squared from here minus 6b is equal to minus 5. That means I have b squared minus 6b plus 5 is equal to 0. So to factorize this, I mean, we've done this a couple of times. So that means b squared, I mean, to get this, it has to be like minus 5b. Let me even do minus b minus 5b. Anyhow, it's fine. So minus b, minus 5b minus b is same thing. But minus 1 times minus 5 is plus 5. That's why I'm choosing that too. Two factors of 5 that will give us two factors of positive 5 that will give us that when we add we get minus 6. That's minus 1 and minus 4. That's why we have minus 1b minus 5b right here. Okay, so that I can even factorize 3. So I have b into b minus 1 minus 5 into b minus 1. So there's minus outside, so the inside it has to be minus 2. So in this case, now I have b minus 1 into b minus 5 equals 0. That is, the positive changes to minus because we have minus out here. So we have b equals 1 and b equals 5. But that's not the end of the story, right? Because when we started out, we didn't start with b, so we started with x. So we recall that 5 raised to power x is equal to b. So we now take at b equals 1, it means 5 raised to power x is equal to 1. That means 5 raised to power x is equal to 5 raised to power 0 because anything raised to power 0 is 1. So, and we need 5 here. So this simply implies that x is equal to 0, one of the solutions. So at b equals 5, I think that's the other result we got. B equals 5. So at b equals 5, it means 5 raised to power x is equal to 5. That means 5 raised to power x is equal to 5 raised to power 1. So that simply implies that x is equal to 1. Okay, so uh so we have x to be 0 and 1. So as usual, you may want to take the pain to check to be sure what you have done is right. So we can do a check. So check. So for x equals 0, for instance, we just put it here. We have 5 raised to power 2 into 0 minus 6 into 5 raised to power 0. That means we have 5 raised to power 0 minus 6 into 5 raised to power 0. That is 1 minus 6 times 1. That's minus 5. Check. That's correct. The other one, we have x equals 1, right? Because we got 0 and 1. For x equals 1, we have 5 raised to power 2 times 1 minus 6 into 5 raised to power 1. So that means we have 5 raised to power 2 minus 6 times 5. That's 25 minus 30, which is minus 5. Correct also. So that's how to check. So we are good with that. I feel I should do one that involves all these numbers. Okay, my eyes keep going to number 5. 7x plus 1 plus 7x equals 392. Okay. 7x plus 1. 7 raised to power x plus 1, that is. Okay. 7 raised to power x plus 1 plus 7 raised to power x equals 392. So first off, we know 7 raised to power x plus 1 is the same thing as 7 raised to power x times 7 plus 7 raised to power x equals 392. We can factorize, so this is one term, this is another term. We can factorize 7x from both sides. So we have 7 raised to power x into 7 plus 1. You know, when you factorize, you divide both sides by that 7x. So, and this is equal to 392. All right, so that means we have 7 raised to power x into 8 is equal to 392. So we can divide through by 8. Now we have 7 raised to power x times 8 equals 392. And we divide both sides by 8. This is divided by 8. This is divided by 8. 8 cancels 8. So we have 7 raised to power x equals 8 here is 1. 8 in 30, 8 in 39 is 4 times, right? That's 32. We have 7 left. There's 7. We have 7 left, right? 8 in 39. That's 32. That's 4. So we have 7. 8 in 72 is now 9. Okay? So now everything becomes easy. We now have 7 raised to power x equals 7 raised to power 2. Okay. And then we can compare the powers. So we say x is equal to 2, and that's exactly the result. But can we check x is equal to 2? So for x equals to, since we got x to be equal to 2, so to check, so we are checking this now. So we have 7 raised to power 2 plus 1 plus 7 raised to power 2, and that is equal to 7 raised to power 3 plus 7 raised to power 2. That means we have 7 raised to power 3 is 343. That's 7 times 7, 49 times 7, 343 plus 7 raised to power 2, that's 49. So if you add this up, 12, 9, 2. Okay, that's the same as this. So we are good to go. So with this, we come to the end of this interesting video on solving indicial or exponential equations by factorization. So try your hands on all the questions. Here you have 1 to 10. Here you have 11 to 20. Try your hands on them and see how well you can master them. You understand this concept, okay? Yeah, so with this, I come to the end of this video. Let me know how helpful this is for you. And if there's something else you'd like me to try out, feel very free to let me know. If you have subscribed already, I must thank you very much for doing that. If you have not subscribed, the question is why haven't you done that? So go ahead, subscribe and hit the notification bell so you can always get alerted each time a new video is released, right? Having done that, you can also become a member of this channel by clicking on join. That gives you some special privileges, like you get to see some videos first, or some videos are made just for you as a member of the channel. And then, of course, we can get to hang out together either online or offline to discuss whatever interests you on my channel. Okay. Um, Ultimately, don't forget to comment, like, and share so that more people can have access to the great content I have going on here. Till I come your way again, keep doing maths right. Bye.